We have our mineral sets out again, and we are back in our science book looking for more ways that we can identify which mineral it is that we are looking at. Last time we talked about the color and the streak. This time we're going to talk about luster and cleavage and fracture, and then we will move over to hardness. So when they mention luster, I wrote some notes here that you might want to add to your book. That means how much sparkle is there. Mineralogists do not say shiny. That's not really a science word. How much sparkle is there to this particular mineral? So if we look at the examples that they have up here at the top, we can see that they've got 8 different examples there. But right here, it says there are 2 major types of luster. Those are metallic and non-metallic. So that's really the big one that you need to know, that they are metallic or non-metallic. You don't have to memorize all of those. But if you take geology classes later, they will ask you that. So over here, I have a couple of piles of minerals that I've kind of sorted out. And this is a pile that I would call metallic. And this is a pile that I would call non-metallic. Now, I say what I would call because there is a little bit of opinion that goes into these. If I pick up one like this and I turn it around, I can see some reflectiveness there that I would call little flecks of a metal. So I would call that metallic. Someone else might say that those are little flecks of something that is more pearly, like this, that just happen to be embedded in there. So someone else might say that that one is not metallic, but some of them are definitely easy to identify as metallic. There are a few that are a little trickier, like over here. These technically are metallic because they have copper in them. You know what a penny looks like after it has become exposed to the elements? It starts to turn a greenish or a blue color, and these do have copper in them, and so those would be classified in the metallic group if I were doing the sorting. But someone else might move them over here because they don't see that on the surface. They might want to break it and look inside. Let's take a little look at the ones that they have in our book. Here is metallic up here. So we have some metals. This has some silver in it, and this one has some lead in it. That's galena. The next one they talk about is silky. So for silky, we have this one right here, which is asbestos. Kind of looks like glass celery. Those little fibers on it made it very useful in industry. They would tear those little fibers off of there and mix them into plaster, and that made it hold together really well. But then years later, when you took that building down and you breathed in those little fibers, that was not good. But that is a silky texture. In this mineral form, that is not harmful to us. Here is another one that has that same silky texture. This is called satin spar. It does kind of look like a ribbon there. That one does not fuzz off like the other one, though. A little bit harder mineral. Vitreous means glassy. There is another word for this. It starts with an A. It's like adamantine or something that's hard to say, but for us, glassy is fine. Waxy texture would be something you would see in this turquoise right here. I have a ring made out of that. Submetallic is a little bit harder for me to understand. Sub means under, and metallic obviously is metal. To me, this one doesn't look very metallic. This is sphalerite, which is what they have pictured there, but to me, I would pick up a piece of sphalerite and I would call it glassy. So it depends on which mineralogist is doing the sorting. Here's a piece of coal, and I can understand that maybe a little bit better as submetallic because I can see some iridescent, kind of like you see the oil floating on top of a water puddle sometimes. I can see that in the coal. That looks a little bit more metallic, not totally metallic, but maybe submetallic to me. This muscovite is pearly, has a pearly texture to it there. Resinous, this almost looks fake, looks like scrambled eggs. This is sulfur. Scratch that with our thumb and smell it. It would smell like a match head. That is described as looking like tree sap or maybe gum or plastic. It does not look like a rock. A lot of kids think it's fake. An earthy texture would have a dull or clay-like texture. Okay, so moving on down here to the bottom. Next, we're going to talk about cleavage and fracture. That is the tendency of a mineral to split along specific planes of weakness to form smooth, flat surfaces called cleavage. A plane of weakness. A plane is kind of like the faces that you saw in math when you were doing cubes and rectangular prisms. So if we look at this muscovite right here, muscovite is very similar to the biotite mica that has a black color to it. This one has a white color to it. This would have been a big chunk, but when you drop it, it would have broken into these very thin sheets. This is what some of the early settlers made their windows out of. And some of you might even have some thin pieces of this as a little window in a kerosene heater or space heater at your house, because it is a mineral, non-flammable, which you can see right through that. Here are some other examples. Here is calcite. If you drop calcite, you get this parallelogram kind of shape there. And here is another example that you should be familiar with. This one's actually a rock, not a mineral, but I know it's something that you're familiar with. This is a rock that breaks very thin, shale. There is tons and tons of shale in Cardington. So I know that you have seen this as you go at Heimlich Park or close to any of the areas there. So that's what they mean when it has cleavage, that it makes a clean break. Flint has what they call a conchoidal cleavage. That's kind of interesting. When you break it, it makes these little like curved little dents to it. So here is a piece that has just naturally broken on its own. I don't think that's an Indian artifact, but here's one that I found while we were off in my friend's creek, and you can see all those little divots along the edge where they just pressed on it with a piece of antler or another hard rock, and those pieces popped right off, helped them to shape that. Flint is our state gemstone. Comes in a lot of different colors. That was the bonus question. Some of you had trouble finding where that was. That think outside of the book. That was right here. Think outside of the book. Find out what your state mineral is and how it forms. We don't really have a state mineral, but we do have a state gemstone, and it is flint, known for its beauty. Very pretty when you polish that all up. Next, we are going to turn the page and talk about hardness.